Given f of x is equal to the square root of x minus 3 and g of x is equal to x squared plus 5, we want to find f circle g, and then we want to find g circle f. So let's start with the first one. F circle g of x. So f is the outside function, g is the inside function. So this is f of g of x. G of x is x squared plus 5. So replace it. So this is f of x squared plus 5. That means that on the f function, wherever we see the x, we put in x squared plus 5. So we have the square root of x squared plus 5 minus 3. So this is the square root of x squared plus 2. Let's get number 2. We want g circle f of x. So here g is the outside function, f is the inside function. So this is g of f of x. Start with the inside function, f of x. F of x is the square root of x minus 3. So this is g of the square root of x minus 3. So here on the g function, wherever we see the x, we put in square root of x minus 3. It is a good idea to put the parenthesis around the x when we do this. So we have the square root of x minus 3 square plus 5. Here, the square and the square root cancel out. So we have x minus 3 plus 5, which is x plus 2. Given f of x is equal to x minus 5 and g of x is equal to x squared plus 2, we want to find f circle g, and then find the domain of f circle g. And we want to find g circle f, and then find its domain. So let's start with the first one. F circle g of x. So this means f of g of x. F is the outside function, g is the inside function. Start with the inside function, g of x. G of x is x squared plus 2. So this is f of x squared plus 2. So this means that wherever we see the x in the f function, we put in x squared plus 2. It is a good idea to just put a parenthesis around the x. So we have x squared plus 2 minus 5, which is x squared minus 3. Let's get the domain. The domain of a composition function contains 3 steps. The first step is to get the domain of the inside function. Here, the inside function is g. So we want to find the domain of g, and the function g of x is x squared plus 2. So we want to find the domain of x squared plus 2. If we look at this here, we have no fraction, we have no square root, no even root. So this means that the domain is all real number. The second step is to get the domain of f of g of x, which is the domain of what we found, x squared minus 3. With this again, there is no fraction, there is no square root, so this is all real also. So the final one is the domain that we want, the domain of f circle G. The domain of f circle G is the combination of the first two steps. So the first step, the domains are real. The second step, it is also all real. So there is no number where we have to exclude. So that means the domain of f circle G is all real number, or from negative infinity to infinity. Let's get number 2. We want G circle f of x. So here G is the outside function, f is the inside function. So we have G of f of x. Start with the inside function f of x, which is x minus 5. So this is G of x minus 5. So that means that wherever we see the x in G, we put in x minus 5. It is again a good idea to put a little parenthesis around the x. So here we have x minus 5 squared plus 2. So that is x minus 5 times x minus 5 plus 2. Boil it, x times x, so that is x squared. X times negative 5, so negative 5x. Negative 5 times x, so another negative 5x. Negative 5 times negative 5, so positive 25 plus 2. Like terms, so we have the x with the x, the number with the number. So this is x squared minus 10x plus 27. Let's get the domain. The domain again contains 3 steps. The first one is the domain of the inside function. The inside function here is f of x. So the first one is the domain of f of x, and f of x is x minus 5. So here, x minus 5, there is no fraction, no square root, so this is all real. The second one is the domain of g of f of x, which is what we found here. X squared minus 10x plus 27. So for this one, we don't have fraction, we don't have square root again, so this is all real number. So the third one is the domain that we want. The domain of G circle F is again the combination of the first two. So the first step, the domains are real. The second step is also all real. So this means that the domain, there is no restriction, it's all real, or from negative infinity to infinity.